Now we'll explain about the copying process of the DP6570. The copying process consists of charging, original scanning, image processing, laser exposure scanning, development, transfer and separation, fixing, cleaning, and discharge. While charging, the 0.06 mm diameter tungsten oxide wire is biased at about -6 kilovolts, and the charger grid is biased at -720 volts. As a result, by applying a charge to the surface of the photosensitive drum evenly, the electrical potential of the surface becomes -650 volts. An OPC drum with a diameter of 100 millimeters is used. In original scanning, the light irradiated to the original is reflected. The reflected light corresponding to the density of the original is projected to a CCD, or charged coupled device, via the mirror or lens. If light is directed at a white area of the original, more intensive light is reflected. If light is directed at a gray area of the original, less intensive light is reflected. And if light is directed at a black area of the original, almost no light is reflected. Then a charge is generated in the CCD corresponding to the intensity of the light. This signal is converted into a digital signal and sent to the image processing section. In the image processing section, corrections are made, or some editing processes are conducted to provide appropriate image quality. Then the image signal is finally sent to the laser exposure scanning process. In the laser exposure scanning process, the laser diode is turned either on or off, depending on the image signal. At this time, the electrical potential of the drum surface at which the laser beam is directed gets close to 0 volts, and the potential of the drum surface at which the laser beam is not directed remains at -650 volts. As a result, a latent image, which cannot be seen directly by the human eye, is formed on the drum surface. In the development process, the negatively charged toner and the positively charged carrier, which were mixed in the developer unit, are transported and gently brushed onto the drum surface by the magnetic roller. In laser exposure scanning, the electrical potential of the drum surface, which is exposed by the laser beam, becomes lower than the developer bias, which is -400 volts. So negatively charged toner adheres to the drum. 1.5 kilovolts AC at 6 kilohertz is superimposed on the developer bias, and generated electrical vibrations enhance the development efficiency. Since the electrical potential of the drum surface which wasn't exposed is more highly negative than the developer bias, negatively charged toner does not adhere to the drum. Since the charging polarity is the same as the toner sticks on the exposed part. This is called the reversal development method. Since this method is beneficial for laser exposure scanning and provides longer life for the laser diode, it is used for most of the digital copiers. Since the drum and developer are driven separately, the magnetic roller and developer bias are turned off before the charging output is turned on, to prevent the unwanted toner from adhering to the drum. In the transfer and separation process, voltage of about 2 to 4 kilovolts is applied to the flat rubber transfer belt coated with a conductive material via the power supply roller by passing a current of 50 microamperes. Then the paper is statically polarized, and the toner on the drum adheres to the paper by electrostatic attraction. Unlike the conventional corona transfer system, in the transfer belt system, transfer is performed with the paper adhering to the transfer belt completely. Thus, transfer efficiency is stabilized constantly, and a constant transfer output is applied between the leading edge and the trailing edge of the paper. In addition, if no paper is present in the transfer process, the power supply roller output is turned off to reduce the amount of ozone generated. By electrostatic attraction acting between polarization charges on the bottom surface of the paper and the transfer belt, the paper adheres to the transfer belt and separates from the drum along with the toner. If the paper does not separate due to a problem with static absorption or moist paper, the paper will be forcefully separated from the drum by the separation claw in order to prevent paper jams in the cleaner unit. And the paper will separate from the transfer belt where the belt curves. Paper dust and toner adhering to the transfer belt are scraped off by the cleaning brush, which is biased at 300 to 700 volts by a current of 5 microamperes, and the cleaning blade, and then collected into the toner box by the recovery auger. The toner adhering to the cleaning brush is scraped off by the flicker. In the fixing process, the 200 degrees Celsius of the heat roller and the pressure of the rubber roller fix the toner permanently on the paper. The silicone roller and the felt roller are installed to clear toner and paper dust from the heat roller. And the silicone roller and the metal cleaning roller to clean the pressure roller. And there are separation claws to separate the paper from the heat roller and pressure roller. To enhance subsequent cleaning efficiency, lowering the electrical potential of the drum surface allows paper dust and residual toner to be cleared from the drum by the grounded conductive fur brush. The toner adhering to the fur brush is scraped off by the flicker. In the cleaning process, the toner remaining on the drum is scraped off by the main blade and collected by the recovery blade. The collected toner is then stored in the toner box. Finally, to even out the charge on the drum for the next charging step, the light from the discharge LED array, where 16 red LEDs with a wavelength of 616 nanometers are arrayed, illuminates the entire drum, and discharge is performed. That is the copy process. But depending on the drum counter, the development counter, the drum thermistor, and the toner adhesion amount sensor, the following controls are performed for high image reproducibility. As the drum is used, the electrical potential of the drum surface gradually becomes lower. As a countermeasure against this, the charger grid voltage and laser intensity are raised, corresponding to the drum counter. When the drum counter reaches 190,000, which is equal to 400,000 copies for the DP6570, the charger grid voltage is raised by about 4% from the initial, and the laser intensity by about 17%. And in order to fit into the characteristics of the developer material, when the development counter is between 0 and 50,000 for A4 letter, the charger grid voltage is increased by about 8%. Along with that, the laser intensity is increased by about 4%. And furthermore, the developer bias by about 25%. In addition, the rotation speed of the magnetic roller is raised by about 8%, or by 2 bits. Additionally, after the auto-toner sensor is adjusted, the auto-toner sensor control signal is raised by 7 bits to stabilize an image. The charger grid voltage is varied by the drum thermistor according to the drum counter at between 10 and 50 degrees Celsius, in the range of about 4 to 15%. In addition to these controls, control is performed by the toner adhesion amount sensor in order to maintain image quality corresponding to the actual operating environment and use of the drum and developer material. A 14 by 50 mm half-tone pattern is developed on the drum when a pre-run is completed, or when 2,000 copies are made, and then its density is detected by the toner adhesion amount sensor. Thus, by reflecting the result of the density detection throughout the process controls performed by the counters and thermistor, the image can be better maintained.